Hello, my name is Josh Sawyer. This talk is called Game Programmers, the Heart of the Machine. To just give you a rundown of what this talk is about, this is about communication and collaboration. Just so you know, I am not a programmer, not an engineer. I'm a game designer and a game director. So you all are mysterious, powerful beings, wizards that make games possible. I'm just a designer. This is about how to best communicate with designers to have a productive workflow. It's not about technology, it's not about engineering outside of very high-level sort of principles. It is about focusing on the experience, which is what games are ultimately all about. Games are about experience. At the end of the day, someone is going to get that game, and they're going to have an experience with it, and that is the proper focus for development. After all is said and done, that's what you're going to put into a box and give to someone. For a little bit of background on who I am, I'm the design director at Obsidian Entertainment in Irvine, California. I've been there for, I guess, 11 years now. I've been in the industry since 1999. I was the game director and system designer for Pillars of Eternity and Fallout New Vegas. I started my career as a level designer on Icewind Dale at Black Isle Studios, and I was the lead designer on Icewind Dale 2. So I have a large background in making role-playing games, primarily PC role-playing games, but also console games as well. So here's where we get to talking about how amazing you all are. You are powerful wizards that make games happen. Without programmers, it's pretty hard to have a game. You implement all the features that we request. You engineer all the systems we use to create content. You make our pipelines possible. Without you, we couldn't get half the things into the game that we wanted to. It's where all the disciplines of game development meet. So what is the problem? Well, designers are not engineers. We don't often know the best way to talk to you, and sometimes you don't know the best way to get good information out of us. Either we give you too little information, sort of self-explanatory what the problem with that is. Also, we can give you way too much information, or we can do pseudo-engineering, which I'm sure you all love. I'm sure programmers really love being told how to do their job by designers. If we don't make it clear the order in which we should do things, prioritization can be a big problem. And if we have poor iteration loops, that can cause many, many, many problems as you're approaching the deadline of getting your game done. I will admit that a lot of the assumptions in here rely on certain methodology bias. Early in my career, we used a lot of waterfall development where designers would design something that would just kind of get passed down the line and implemented, and then someday in the distant future, we would look at it in the game and go, oh, that's really not what we wanted. Let's do that all over again. Agile development, in my experience, has worked much better, or variants of agile development have worked much better, in part because game development is about creating experiences, and often that is a very subjective thing that requires looking at things in context. So having tighter loops of iteration, in my experience, has worked very well. So let's talk about each of these problems in turn. Designers are not usually engineers. We are at our best when we're focusing on a few things: goals, needs, and constraints. Goals, what's the point? When we ask for something, what are we trying to accomplish? This might seem like an obvious thing, but often designers request things and it might not be clear exactly what we're going for. Sometimes there may be an easier way to get what we're asking for that is not specifically what we're requesting. Knowing what the goals are at a very high level can help shape engineering decisions and also design decisions. When we talk about needs, and this is a sort of basic high-level design thing, it's not specific to games, it can be applied to making furniture, it can be applied to making automobiles, many things. What are the needs and what are the constraints? What are the needs? What are we trying to accomplish? What's our goal now and in the future? What are the individual features that we need to get to that place? And then what are the constraints in place that are limiting how we approach these problems? Those problems can come from the publisher, they can come from audience expectations, and they can also be technological limitations. Technological limitations are not necessarily things that prevent us from doing things, but they may make it more difficult to do things in a certain way. What's the problem with lack of information? We kind of know this, but let's go over it anyway. Poor documentation or ad hoc tribal knowledge, meaning information passed along through email chains or just impromptu discussions that you have while meeting in someone's office, that's a poor foundation for actually implementing something, because it's very easy to misunderstand what people's goals are or forget them. And the needs and constraints aren't really well established. You have a little bit of discussion, you go back and forth, each person involved in that discussion kind of thinks they know what's going on, and then you go off and make something and then come back later and go, oh, wait, this isn't actually what I thought it was going to be at all. If we give you too much information, it can make a very time-consuming loop. Basically, we designers, we sit down and we write a 30, 40, 50-page document. I know that sounds ridiculous, but I've certainly been guilty of writing much longer documents than that. I write it, engineers have to look at it and tell us how stupid we are. They mark it all up, then it goes back to us, we revise it, then it goes back to the engineers and they have to review it again. On a project that has a lot of given features, that loop can take a long time if the documentation has a lot of superfluous information that doesn't need to be there. And designers also, especially when the documentation starts to get big, we will start pseudo-engineering. We start telling you how to architect things. Very rarely that is necessary. It is not actually usually that necessary. If we're telling you what our goals are and what our needs and constraints are, that's usually enough to work out on your end how that should be approached. And prioritization can be difficult because there's a mountain of information to sort through. What should we do first? What should we do second? What features are things that can wait? And what features are things that need to be done right away to make sure that it's actually a viable feature or set of features to accomplish a goal. Poor prioritization can make things very, very complicated. If there are too many requirements to make something viable, like this, if to achieve our goal, we need all of these things, and there are 12 things. Well, if that's going to take 3 months, that could be very difficult to iterate on because it will take a long time to get to the point where you can even review that thing in context where it makes sense to see if you're getting where you're trying to go. And if there are too many different priority levels, you can confuse what is necessary for viability with what is with what is not necessary, what would be helpful. In my book, really, there are two things that are necessary and things that would be helpful. It clarifies a lot of things. And a poor iteration loop can miss the mark very easily, and the mark is ultimately that experience that you're trying to create for the players. If you don't iterate early and regularly, it can be very difficult to course correct on your trajectory. We make certain assumptions about design that at the end of all of these things, it is going to be fun for the people who play the game. And if you're not actually looking at it in context, you might be doing all the things that you set out to do in a technical sense. We have these features, they win in the game, they work properly, but it can be not fun. And if that is your goal, which I would hope it is, if you don't iterate on those things very early and regularly, it can be very, very difficult to course correct. If you start building pipelines and content on top of a flawed implementation, you're incurring development debt. So people are doing things the wrong way under the assumptions that it is the right way, and then 9 months down the line, you're gonna say, oh wait, you know what, we don't really wanna do it that way. Please redo all the content that you did, or learn a new content development pipeline so we can do it the way we actually wanna do it. That is also very bad. And if you, and I mean this generally as game developers, if you do not play the game, you will not understand the context for which you are developing the features that you're making. Obviously, it takes a lot of time, and I know a lot of people grumble, which is strange as game developers. A lot of times you'll find developers grumbling about playing the game, but it's very important that you actually play the game and understand the context in which features are implemented so you get what we're going for. Or you can say, I don't understand this, I don't get how these things are supposed to work together, which is also very good feedback. So, what are we supposed to do about all this? First, and by the way, these are all just based off of my own experiences. This stuff has worked very well. I would be lying if I told you that I worked this way all the time. It's only after 17 years that I've reached this point of going, you know, this is probably the best way to do this. When you first start talking about the goals, talk about the concepts, the high-level ideas that designers are going for. On the technical side of things, talk about known capabilities of your technology and known limitations. This isn't about shooting things down, it's about providing a space for designers to think within, sort of framing their understanding of how the technology works. When it comes to documentation, designers should focus on establishing goals, needs, constraints, and features with an A or B priority. I'll get back to this, but A and B are really all you need. I have yet to see a team that gets through every A and B priority feature for the games that they're making. On the technical side of things, when you're specifying your technical design, you need an ordered plan for how you're going to approach those features. You need to identify risks in the implementation, along with plans for risk mitigation. Just identifying a risk in itself is not enough. You also have to say, by the way, these are how I plan to address the risks in this implementation. and also address scalability and extensibility. Designers love asking for more. Like if we say, hey, can we have X? Soon we're going to want X times 10. Like we're going to take that thing and we're going to try to bend it and do all sorts of crazy things with it. So at the documentation stage, thinking about how you might scale it or how you might extend it to different functionality is worthwhile. Once you have come up with these plans and you're starting to work on things, you, and I mean this as the team, need to establish and maintain a timetable for review, revision, and iteration. The important thing here is pay attention to found work. A lot of times, people kind of neglect that found work is part of this process, and it doesn't go into a schedule, and it's not accounted for. And at the end of 3 or 4 or 5 months, you go, oh, geez, we only got through half of these features. I don't know where all the time went. Well, it went into found work. Nothing ever really goes exactly as you expect it to, especially not in game development. So accounting for found work is very important. I have a mantra which is core before more, which means get the core features in, check those out, and then start sprinkling all the little delicious bits on top of that. Doing things sort of in a weird order can result in wasted work or not necessarily getting the core things and they'll let you evaluate what you need to. Play the game and see the features in context. Once you start getting a lot of these things in the game, actually sit down and play it so that everyone understands, oh, so that was the point of doing all this stuff. This is how it feeds into other systems in the game. So let's talk about the planning phase. This is where designers and programmers get together and have a little chat about how things are going. This isn't really the brainstorming phase. So let's assume that whether it's just a brilliant idea that one designer had or a group of designers got together and chatted about it, they have an idea for something they'd like to do. Not brainstorming. This is about ideas and high-level concepts. Again, the goals, what they're kind of going for. I have an idea, like, I think in this game there could be this really cool dynamic weather system that did all the stuff, and there'd be lightning and a sandstorm, and you're like, okay, cool, keep going. Like, just so you know, like this is kind of how the tech works, and we could probably do some of this stuff, and it might be a little more challenging to do that. It's an overview of known technical capabilities and limitations. Again, this frames the understanding that the designer has moving forward into documentation. I mean, the designer could just write down their hopes and wishes and dreams, but it is nice when a designer has some understanding of how the technology works before they try to make that, that list of wishes up. This is not the time to shoot down ideas, but just to help shape them. So it's very valuable for a programmer to say, hey, just so you know, this particular part of your idea has these challenges based on the technology base that we're using. It might take a little bit longer, or it might be complicated in this way. That doesn't mean that you're not going to do them. It's just something to help inform production and design. This is probably going to be the cost of doing this thing. My goal is for designers to have their head in the clouds, not up their ass. You can design something as though there are no limitations. That's kind of silly. With games, we try to push for things people have never seen before, and we should never stop trying to do that. But if we have a little bit of direction, it can go a long way in making a lot more things possible. So when it comes to the first design doc, this is the game design doc. This is on the game design side. If there is one thing that you take away from this whole talk, it's that you should get designers to specify goals at the beginning of any design doc they make. This doesn't need to be a very long thing. It doesn't need to be paragraphs or pages. I just have people do a bullet point. I want to accomplish this and this. I want to make the player feel like this. I want the player to think that this is really cool. I want da-da-da. It's just a little list of things. That's the lens through which you can understand everything else that the person is asking for. Because as you go through there, you can always go back to the goal and say, like, is this really feeding into this goal? Sometimes a designer might go off the path and not realize, oh wait, I'm not actually, this doesn't have anything to do with accomplishing the goal at all. Or it might need some explanation so you understand, like, why do you want this feature? How does this help reinforce the goal? And they're like, well, actually it does this. So goals are very, very, very important. Needs and constraints frame the design side requirements and restrictions. It's very simple, lays that out as clearly as you can. In my book, on any team that I run, there are either A, required, or B, priority features. Anything that is a C priority feature means it is a cut feature. I have never, ever seen a team get through every A and B feature, even for a single set of things. So when A means this is required for viability, and B means these are helpful things that would make this feature or set of features better, it makes things a lot clearer for the developers what should be developed in what order. Always asking for reference is very, very good. That reference can be in the form of videos. It can be in the form of actually having a session where you sit down and play through a game. Like if someone says, oh, have you seen this? There's this really cool thing in this new Castlevania game, this really neat feature that they do. Check it out. And then you all sit down and you watch through it or play through it. You can also see it in a video, but any of that reference can be valuable for not just the programmers, but also other departments understanding what are all the pieces that go together to make this thing work. Do we want to do it similarly to how these games did it? Or is there a way that we might want to make it differently, either based on personal preference, goals, technology limitations, and so forth? Also, if there are any GDC talks or white papers that reference any of this stuff, linking to it is super valuable. We're going to rip off The Witcher 3's reactive music system for the game I'm working on, which the CD Projekt guys gave a talk on it, and it was great. Great ideas. We're going to use them all. Thank you. Now, when it gets time to doing the technical design, there are a few things to consider. One, always link to the design doc that spawned the technical design doc. You may not be, even though you might be the person authoring this document, you're going to have your leads looking at it, you're going to have your peers looking at it. At some point, you might have to hand off a set of features to someone else. If they don't understand sort of the context for why you are making these decisions, it's going to be very hard to understand. So always, for the sake of other people, link to the design docs. Create an ordered plan for how you're going to approach implementing things. Identify the risks with plans for mitigating them. Talk about plans for scalability and extensibility. You do not want to wind up in a corner where you cannot expand upon a feature or a set of features that you've developed. Now, when it comes to the building, testing, and review cycle, this is sort of like the core part of iteration in a sprint. Start building based off of your TDD that you made. And by the way, the responsibility for this might be your personal responsibility. It might be a lead programmer's. It might be a tech director's. It might be a producer's. The point is that somebody needs to make a schedule that sort of plans out when you're going to look at each of these features, test them, review, and iterate on them. The reviews are going to critique the implementation based on the game design doc and your technical design doc. Is this actually accomplishing what we set out to do? And you're going to adjust the plan. Again, you are going to adjust the plan to account for found work. You're going to find work. There's new things you're going to have to do. There are things that you might drop or you might respec, and that has to be accounted for. And then as you iterate, you're going to go back to old issues saying, here are problems that we found before. We want to look at them again. Now let's look at the new features. Again, core before more. Try to focus as much as possible on getting those A features done before the B features. If the A features form what is required for viability, there's not really much point. There are some exceptions where just due to logistics, you do wind up, it makes more sense to implement a B feature, but as much as possible, try to get the core elements that are required for viability so that you can really evaluate those features. I'll give a few examples from my own game development history of things that I thought went okay to pretty good. Here's an example from Fallout New Vegas. Looping reloads. In Fallout 3, which is the technology base that we used for Fallout New Vegas, that was Bethesda's engine, reloads were just a singular reload. So if you had a magazine and a rifle, and you went to reload, the magazine would drop out, you put a new magazine in, and it was all reloaded. There were a lot of weapons that we wanted to have in Fallout New Vegas that were more of a cowboy style. The game is set in the American Southwest, and things like lever action rifles and single action pistols and things like that, they reload in a certain way that if you watch a lot of cowboy movies or if you shoot those guns, you realize like, oh, these feel a lot different. And you kind of need to put a shell in one at a time. And there wasn't any support for that in the engine. But because it's a first-person game, having that experience where you actually see each shell go in, we're like, that's pretty cool because we saw it in a few other games that had done it. And we're like, we want to try to get that feeling in for these weapons because it'll really help with that feeling of like being a post-apocalyptic cowboy. So that was the goal. Just make the player feel like a cowboy with looping reloads. So the needs we identified, we need a reload system that loads a single round per loop. So there's a beginning animation, then there's a looping animation, and at the end of each loop animation, there's a single round that goes in, and then there's a final animation that finishes the reload and cocks the weapon. The constraints from the production and engineering side were, this cannot take more than a week. Spoilers, it took more than a week, but we tried very hard to not place too many demands on what this system was supposed to do. So the A features that we prioritized were the 3-part animation loop, the 1 round per cycle reload, And we wanted support for multiple weapon types. We wanted to be able to do it with rifles and pistols and all sorts of different weapons. As a B priority feature, as a sort of, we were kind of like, well, if we can only do this in a week, we want the ability to interrupt the cycle. So if you have 8 rounds, an interrupt is where you go 1, 2, 3, and you're like, you know what, screw it, I have to start fighting right now. So you could interrupt that cycle and then go back to firing. We specified it as a B priority feature in order to save time. That was a bad idea, but we caught it. So for references, we used a whole bunch of cowboy movies, and then which we all loved watching anyway. And then we used some of the Call of Juarez games. They had a lot of cowboy weapons, and they had these really cool, very close-up reloads. And they worked really well, so animation looked at them to figure out how they were doing them. Programming looked at them. Obviously, there was a different technology base, but they got an idea of how things were broken up. On the technical side, our lead programmer, he said, okay, first we're going to implement the 3-part animation for one weapon without worrying about the looping. Let's just make sure that we can actually have a 3-part 3 animations play in sequence to do a reload. Then they'll do the looping reload where you get 1 round per cycle, then extend it to other weapons, and then the 4th thing was to create the interrupt system. The risks there, the biggest risk was there was nothing else in the animation system that did a loop like this at all. So we had no idea if this would even work or if it would break super early. The way that we mitigated it was programming said, look, we don't know if this is going to be easy or hard. Don't commit art resources to it right now. Just have the animation so we can actually test it out. And get a dedicated QA resource right away because we think this is going to break a lot of things. They were right. And by the way, that rifle on the bottom, that's actually a rifle from Fallout 3. We said don't make a new rifle for the lever action reloads, even though this one wouldn't work normally. It will work as a stand-in for testing this feature out. Scalability, the engineering team said, by the way, each reload has its own ID in the system, and there's a finite number of them. So if you go crazy and add a zillion weapons, which we did, you're going to run out of animations eventually. So they gave us a heads up, like if you want to use this feature a bunch, it's cool, but you will run out of IDs. And then extensibility, we said, we just want to use this looping system for reloads for these lever action weapons, and we don't have any plans to extend it. On the iteration side, we found a few things very quickly. One, it was really cool. We were like, oh wow, that looks awesome, great. Oh yeah, cool, great weapons. It was really buggy. We found that out right away. So we assigned a tester to it. We said, like, okay, try to break this. And it broke in a lot of ways. So right away we found out, okay, this does cause a lot of problems with the system. Also, we found that not having an interrupt to interrupt mid-cycle made it really frustrating. If you have 8 rounds and you're in the middle of a firefight, you go 1, 2, 3, 4, 5, 7, 8. Not having the ability to interrupt that was just excruciating. So it was listed as a B priority feature, but we said we can't do this. Like either we have to get this interrupt feature or we have to scrap the feature or the whole idea. So we had a test plan for regular periodic testing of the feature because it kept breaking in a lot of different ways. Also, we kept patching new fixes in. Even after launch, we found that it broke in new and interesting ways each time. Interrupt was the last thing implemented for it, but we found it was an A feature. So that was something where we thought, oh, that would be a nice feature, but we quickly found through playing it, no, we have to have this. This feature is not a fun and cool feature unless you can actually interrupt the cycle halfway through. And we liked it so much that we extended it to a ton of other weapons. It was very, very easy to extend. And yes, we did run out of animation IDs, but because engineering had told us about it, it was not a surprise. We just checked periodically, like, how many animations do we have left? 8? Okay, how many more? Okay, let's do a few more weapons. And then eventually we exhausted them all, but it was programming telling us about that ahead of time was very, very useful. Here's the second example. This is the project I'm working on now, which is called Project Louisiana. So we wanted to make the world feel more alive through the use of dynamic weather. The last project I worked on was called Pillars of Eternity, and it was a crowd-funded traditional PC role-playing game using 2D backgrounds with some 3D elements in it. And people responded very well to the environments. They're very beautiful environments, but they're also very static environments. And there were certain things that we had tried to do in the first game using dynamic cloth elements and foliage, and we tried them out and they didn't really work very well. And we knew that people liked the environments, but we also saw them saying, God, it just feels so pleasant, it doesn't change very much. It's 2015 when the game came out, and so people are used to environments being much more reactive and dynamic. So we said, okay, for this game, we're going to make sure that we can have a dynamic weather system with lots of elements that are really reactive. It'll feel awesome. So the goal, make the world feel more alive through dynamic weather. So the things that we needed, we wanted a wind system that would interact with environmental cloth and foliage, two things that we had tried before that had not worked. We knew we needed support for a wide variety of visual effects. We said, like, we want to be able to have sandstorms and snow and volcanic ash falling and rain and all these other cool things. And we wanted to be able to group it by region. So we can say, okay, this is the ice region, snow falls here, it doesn't rain ash here. This is the volcanic region, it does not snow here, ash comes down, things like that. And then we needed a weather state manager to make that stuff all actually blend together nicely. The constraints from engineering, they said, okay, take it easy, don't go crazy with weather, because Pillars of Eternity ran fairly nicely on low-end machines, other than loading times. So they said, look, it's cool that you want to have all these dynamic weather elements, but just keep in mind that if we go too nuts with it, it can hurt performance, so just keep that in mind. The A features we asked for were cloud maps. Pillars of Eternity uses a depth map to sort of project shadows and things across the environment as though it's a 3D environment. So we asked for cloud maps that could have these rolling clouds over the terrain as though it were a 3D environment. We needed color grading. So if it's bright and sunny out and then it starts raining and it's still bright and sunny out, it seems kind of strange. So the color grading system changes the saturation and a lot of things to make it look overcast and kind of clamping everything. We already used color grading for our day-night cycle, so that was just extending this. We needed a unified wind system. There were lots of different physics impulses that could be perceived as wind, but they were all kind of different systems in different places, and we knew if this is all going to be convincing, it kind of has to work together. We absolutely needed to get the cloth and foliage systems. Those are the main things that you see wind interacting with in the environment, other than particles. And then we needed the weather state editor and the state manager. For B features, we wanted this distant lightning effect that they weren't quite sure if we could pull off. So we said, okay, that's not super important. We knew that there was probably going to need to be some work on smoothing the transitions out, because we had just kind of predicted that some of the things might not look great transitioning from one thing to another, but it wasn't vital for getting the system to work. And then the last thing was gameplay effects. And you might say, like, well, it's a role-playing game. Why isn't that on the A list? Well, because again, the goal was not, change the player's gameplay with weather. It was to make the world feel more dynamic and reactive with weather. So the gameplay effects were actually a B priority feature. References that we used, we looked at the Witcher games. Ever since the first Witcher, there was a lot of cool dynamic weather effects and reactivity to weather. Fallout 4 introduced some cool dynamic weather systems. Stalker, Call of Pripyat, had some very cool dynamic weather elements. And then finally, Temple of Elemental Evil was a 2D game that used some 3D foliage in it, and we looked at how they integrated that into the 2D backgrounds. So on the technical side, plan was first implement cloth and foliage. We had tried this before, and it did not work well. So we're like, okay, if we're going to do this, we have to make sure we can get cloth and foliage. Then work on cloud maps, color grading, and rain. Then weather-specific wind, separate from all these other sort of physics impulses that can sort of be wind-like. Then we needed the data authoring system to say, like, okay, within this region, this is how the weather works. And then the manager governing the system behind the scenes. The risks were, we knew we had tried cloth and foliage before, and the programmers also said, hey, just so you know, the wind, we have lots of potential things that can be interpreted as wind, and if we try to unify that as an A priority feature very early, we might actually wind up causing more harm than good. So let's wait until these other aspects are in, and then we will unify it. So this is an example where an A priority feature was put off because it made more sense logistically to do it later. But we did say, we are going to do it, we're just going to do it later. And hey, I just went through all my mitigation steps. As we iterated on this, we had a technical artist who had some very good ideas for using shaders for simple cloth and foliage. They worked out very well. They were not hard to author. Well, they weren't hard to author, at least initially. They were inexpensive on the game side, and yeah, they just performed very well. So once we saw them in the environment artist said, okay, cool, we're going to use this as much as possible in the environments without going crazy, but we'll try to make sure that there is dynamic cloth and foliage in almost every scene. it's important to do that early in a pipeline so that you don't have 9 months worth of levels done, and then you say, what do you guys think about having dynamic level or dynamic foliage in all the levels you already built? And then they have to go back and tear them all out and redo it. The early reviews of rain, it was very obvious that there was more work that would need to be done to make it look convincing. So what we would have, for example, in a scene like this, is the rain would fall, and if you didn't see something around the edges of these buildings, like things dripping down, it just looked like there was a sheet of visual effects playing over the lens of the screen. It didn't really look like rain was falling in the environment. So the environment artists and programmers worked together to do things where you tagged things in the environment to do that dripping effect, and it looked much more convincing. There's another thing where we had this wind system, and the wind could change direction in almost any direction, and it can do it really fast, and it looked really bad, because that's not what wind does ever. Wind doesn't just, blow 20 miles an hour this way and then switch and blow like 50 miles an hour that way. So it would switch like that, and all the cloth and the particles would look really stupid in the level. And it seemed obvious. We're like, okay, of course that doesn't work that way. So because we looked at it very early, though, we realized, okay, let's back up. Let's put some constraints on this system and make sure that it transitions in a way that's convincing. And when we looked at how the rain and wind interacted, that became the main focus of the smoothing states. We knew we would have to do some things to make those states transition well. The wind and the rain were the two major things that, when they were off, they looked very strange. And instead of being a cool, immersive element, they became distracting because players are going like, what the hell is going on with that rain? Like, why did the wind... And so we needed to put more effort in that to return it to the state that we wanted, which is to make it feel dynamic and cool without being silly. The other thing, too, is that once we had all these beautiful features in and we had them in a real level and we played the game, we noticed that we'd get these gale force winds and these huge storms, and you'd have people that were walking over and they're like, hey, how's it going? You having a good day? And we're like, there's a storm going on. Maybe the AI should react to this. And again, going back to games like the original Witcher, there are a lot of games where people do react to those, or actually Call of Pripyat does a really good job of having the NPC AI react to the weather state changes. So he said, if we're going to really sell this and make the world feel alive, then the NPCs need to react to this stuff as well. So here are some conclusions, just to bring this all together. Start off by discussing ideas, then focus designers on setting out their goals. This will make everything much easier to understand for anything that they're asking for. What are you trying to accomplish? Specify a simple and comprehensive plan. You do need to address everything that's being asked for. You need to address risk, and you need to allow room for growth. You need to at least think about it. Actually, that's another thing. If you say, by the way, there is no way for the system to grow, or it can only grow this much, which is what programming told us with looping reloads, that in itself is still valuable information for designers. Review, revise, and iterate, and always keep in mind found work. Always, always, always account for found work when you find it, adjust that schedule, because that time doesn't get made up. It never, in my whole experience, 17 years, I've never seen suddenly like, wow, all that time that we thought we lost, we actually caught, and we're back ahead of schedule. Never happened. And then test for achieving the goals within the context of the greater game experience. Play the game, because ultimately that is the thing that you are making for the audience. Thank you very much. And I believe I do have time for some questions. Yes. And there's a microphone that's coming your way.
I have a question about budget. So with Pillar of Eternity, probably it was easier because you had a budget at the very beginning. But with Icewind Dales, it was quite a risk that you had to first implement. It had to be successfully to get money back. So how that was in the planning phase? That you could specify, okay, we have 2 years, and how did it affect which was priority A, which was priority B?
Well, I will say, for something like Icewind Dale, it's a good question. So it's about prioritization on something where you don't necessarily know the scope as well, or the budget as well. So Icewind Dale, we didn't know what we were doing, just to be honest. I mean, almost everyone on the team was a junior. I'm amazed that we finished that game at all. Thankfully, we did have producers on that team that, because there were so many unknowns about that technology, they were very, very careful about letting us modify anything. So most of what we did on Icewind Dale was content generation. We did not implement very many new features. It was BioWare's code base. We knew it kind of well from Planescape Torment, but it was actually a different code base. So when it came to risk assessment, we were extremely, extremely conservative on that game. Also, because most of the people on the team were juniors, we lacked the ability to critically analyze things, I think, in the way that we did with Pillars of Eternity. Pillars of Eternity, we were even less familiar with the code base because it was Unity, but we had many more people that understood kind of the risks inherent in some of the pipelines and the ideas that we were discussing. So as we approached them, a lot of it was experience-based. Like, when you have an experienced person who's like, that's another thing too, is that if you actually don't know how to analyze a system, you're like, I've never done anything like this before, then finding another engineer who has experience either working directly with that technology or on a system that is similar can be extremely illuminating. That person can say, oh yeah, we tried doing this on this game and it caused these problems, and these are things that you might want to keep in mind, and then that can go into your analysis. Does that help? Cool.
You were talking about too little or too much information for the programmers or the designers. When you look at most of the old interplay games, like Baldur's Gate and Fallout, for example, they are legendary for their incredibly detailed design documents. For example, the Fallout Bible. Do you think that's also a correct approach to some extent, or would you have done it more in a more modular way, for example?
I would have gone a lot lighter. I mean, I think it's my experiences working at Black Isle that kind of convinced me that we can go a lot easier on the documentation. I would say for the Fallout Bible, I can't obviously speak for Chris Avalone, but I think part of that was for him. It was almost more for himself than it was for the development team. I mean, obviously it was helpful for us, but for example, when I worked, there was a canceled project at Interplay called the Black Hound. I personally wrote 1,600 pages of design documentation for that game. That's idiotic. No one's going to read all that stuff. I mean, I can go back through and be like, oh, it's very impressive. But at some point, someone is going to sit down and actually make the game, and you guys need to be able to program. If you're spending all of your time going through documentation, that's not very productive. And the thing is, like, obviously, you guys can always ask for more information. My goal with all of this is to try to find the place that's the right balance. Like, what's the right amount of information that's actually going to help you understand exactly what we're trying to go for, and then implement features in a way that it just doesn't bog you down with paperwork or leave you going like, I'm supposed to be doing some feature, I don't really understand exactly what it's for or where all these features kind of tie together. So that's kind of the point there. But I do think that at Black Isle, we over-documented things, and at Obsidian, we've decreased. I mean, we still document a lot, but we really try to keep each document very focused.
Excellent talk, thank you very much.
Thank you.
You did mention that designers are not engineers, which in the general case is true, but I wondered if you had worked with anyone who'd crossed the stream from engineering into design.
Yes, Tim Kaine. So Tim Kaine, who was actually he was not technically the lead designer, he was sort of the director overall on the original Fallout. Tim has a PhD and he's definitely a programmer, and we worked together on Pillars of Eternity, and that was a pretty fruitful collaboration because Tim and I bounced a lot of design ideas across from each other, and because Tim was actually implementing a lot of the features directly, he had a very keen understanding of exactly how that system works. So if you do have a designer who is an engineer, that can be a great boon to you, especially if they understand the code base well.
You mentioned that one has to know the limitations of a technology before starting the work on the features you want in the game. So could you give us any examples of features that had to be scrapped from Icewind Dale 2 because of the limitations of Infinity Engine?
Sure. So Icewind Dale 2, I was actually going to give an example from Icewind Dale 2 because that game was insane to develop. We made it in 10 months. And we had to make it into a 3rd edition D&D game when the base game was 2nd edition. So I was going to give an example about how we did multi-classing in there, which was a very crazy sort of thing. And actually I got a letter from Mark Brockington from Bioware, where he said, like, I don't understand how you did that with the engine. But there were certain things that we realized we just couldn't do. For example, attacks of opportunity. There was no real sense of, in 3rd edition D&D, there's this concept of, like, if someone comes near you and you have a weapon equipped, you can threaten them, and then if they move away from you or they do some set of other actions, that can trigger a reaction. We didn't have any notification system to sort of do any of that stuff. We didn't have the concept of really like auras or people being near someone in that way, or at least not in the way that we could really use them. So that was something that we analyzed, and we thought about it. And attacks of opportunity are a really important feature of 3rd edition D&D, but we just said, you know what, this is not going to work. Like, we could try to do it, but every single programmer on the team was like, I really don't see how this is going to come together, especially not on the timetable that we had.
And if I may follow up with a second question, how different is the code of Icewind Dale 2 compared to the code of, say, Baldur's Gate and Icewind Dale 1? Because I'm interested if Beamdog, for example, is going to be able to produce the enhanced edition of Icewind Dale 2, or is it really too difficult to take on that project?
Just briefly, it's extremely different. Yeah, it's they diverge. Basically, starting with Baldur's Gate, Planescape is its own offshoot. Then Icewind Dale and Baldur's Gate 2 went in 2 different directions. And then Icewind Dale 2 just did, we really just gutted a lot of stuff and refactored everything. So, and I think even people from Beamdog have said, like, they don't know exactly how they would do Icewind Dale 2 because it's so fundamentally different from just a gameplay perspective. It would be really hard. But for us, that was the other thing too, is that we knew that, well, actually I shouldn't say we knew that because we didn't even think we were going to make Icewind Dale 2. But one of the things that we had said when we were doing it is like, this is it. This is the end. Like, pull out all the stops. We're never making another game with this technology base again. So there were certain things that engineers might have said, like, well, in the future, and we're like, there is no future. Just like, this is it. Don't save anything for something later. Like, this is the only place that we're going to do it.
Did you ever scale down your feature prematurely? I mean, you thought it will be easier to do, and you told programmers, and they actually said later, well, you could tell us your whole idea, and it would be much, much easier then.
Yeah, we've had stuff like that. So, for example, on Pillars of Eternity, the question is about basically downscaling a feature or sort of like taking it down once programmers have said no. So we had something where rangers had pets, and those rangers and pets behaved in a certain way that was very particular, and it involved a lot of very special little things, and it was a huge nightmare. There was actually this diagram that our lead programmer drew of like rangers and the stronghold and something else, and he's like, these three things come together and form a shitstorm, this perfect nightmare that he can't escape from. And a lot of it was the very specific way that we had asked to implement animal companions. And he kept saying like, oh, I hate these, I hate these, I hate these. And then finally I said, Adam, what is the difficult thing? Like, what is the hardest thing about this? And it was that they could die sort of separately from the player, like actually die. And it was somehow that we were treating them in data that was due to a very specific design constraint. And I said, well, just get rid of it. It doesn't matter. Like I know that's what I had requested, but if I had known that it was actually that big of a deal, just get rid of it. It doesn't. And ultimately, players found the revised implementation more enjoyable anyway. So it saved time on the programmer's end, and it was a more fun experience for players. Hopefully we're not overrunning time.
Okay, so I have a quite different idea, because I'm wondering, in case I would want to go in a direction to become a designer rather than a developer, what should I do when I'm 21? So I have plenty of time actually yet to, go to another direction in the university. Any advice?
Yeah, I mean, I have a ton of advice, and we can talk more after this if you'd like. But one thing I would say is that the biggest asset for a game designer is critical thinking skills. It's the ability to look at a design or a game and break down exactly why it works the way that it does. And also to be objective and understand this is why this design and this particular implementation works for this game and why it might not work in another game. Because usually that ability to sort of deconstruct things and really understand how they come together will then in turn allow you to turn around and put things together that are really cool for your own games. One of the things that I recommend very strongly for anyone who wants to get into game development, especially on the design side, is just to do modding. Like, there are so many engines out there that make it very easy, especially Bethesda's engines. They're very, very easy to use. They're so easy to make little modifications. Start with something small. So I will say, if you want to go into modding, don't try to change the world. Just go in and do a few key things to see how the game changes. It'll really open your mind to understanding how your changes have an impact on how the game is played, and also how the game development process works on a very small scale. And I believe that is probably, that's it. Thank you very much.